Have you ever wondered what mystical journey your carefully crafted prompt takes after you hit enter on ChatGPT? It feels instantaneous, almost magical, but beneath that sleek interface lies a whirlwind of advanced artificial intelligence processing. Today, we're pulling back the curtain to explore the intricate steps that unfold the moment you unleash your query into the digital ether. The journey begins the instant you click send. Your text prompt isn't just a string of words to ChatGPT. It's raw data that needs to be understood. The very first step involves a process called tokenization. Here, your input is broken down into smaller, manageable pieces, often words, subwords, or even individual characters, known as tokens. Think of it like disassembling a complex Lego model into its fundamental bricks. Once tokenized, these textual units are then transformed into a numerical format that the machine can comprehend. This is where embeddings come into play. Each token is converted into a vector of numbers, a multidimensional representation that captures its meaning and context relative to other tokens. This numerical language is the native tongue of neural networks, allowing them to perform complex mathematical operations on your input. With your prompt now in a numerical state, it enters the formidable architecture of the transformer model, the bedrock of large language models like ChatGPT. A critical component here is the attention mechanism. This allows the model to weigh the importance of different words in your prompt relative to each other, understanding which parts are most relevant to generate a coherent and contextually appropriate response. Imagine your prompt as a puzzle, and the attention mechanism is identifying how each piece connects and influences the overall picture. It's not just looking at words in sequence but understanding their interdependencies, even if they are far apart in the sentence. This holistic understanding is crucial for nuanced responses. Next, the encoded, contextually aware input passes through numerous layers of neural networks, often numbering in the tens or even hundreds. Each layer refines the understanding, extracting increasingly abstract features and relationships. These layers are filled with billions of parameters, which are essentially the model's learned knowledge accumulated from vast amounts of training data. These parameters are the memory and brain of ChatGPT, containing patterns, grammatical rules, factual information, and stylistic nuances. When your prompt traverses these layers, it's essentially being compared and processed against this monumental knowledge base, identifying the most probable and relevant information to formulate an answer. The core task of ChatGPT isn't to know answers in a human sense, but rather to predict the most statistically probable next word or token based on the input it has received and its training data. This prediction happens iteratively, token by token. For instance, if you start a sentence, the model predicts the most likely next word, then uses that word, along with your original prompt, to predict the subsequent word, and so on. This iterative prediction process is incredibly fast. The model generates a probability distribution over its entire vocabulary for each potential next token. It then samples from this distribution, selecting the next token to add to the evolving response. This sampling isn't always deterministic. Sometimes it introduces a touch of randomness to make responses more varied and less repetitive. Once a sufficient number of tokens have been generated to form a complete and coherent thought, the numerical tokens are then decoded back into human-readable text. This is the reverse of the tokenization and embedding process, converting the machine's internal numerical representation back into the words you see on your screen. But the process doesn't end with simple word generation. Before the response is presented to you, it often undergoes a crucial safety and moderation check. This involves filtering mechanisms designed to prevent the generation of harmful, biased, or inappropriate content, ensuring the output aligns with ethical guidelines and responsible AI principles. These checks are vital for maintaining a safe and beneficial user experience. They scan for specific keywords, patterns, and contextual cues that might indicate problematic content, attempting to flag or even reroute the generation process if potential issues are detected. Finally, the polished, safety-checked response is delivered to your screen, appearing almost instantly. The entire sequence, from your input to the displayed output, often takes mere milliseconds, a testament to the immense computational power and sophisticated engineering behind these AI systems. So, the next time you hit enter, remember that you're not just sending words into the void. You're initiating a complex, multi-stage dance of tokenization, numerical encoding, neural network processing, probabilistic prediction, and careful decoding, all culminating in the intelligent responses that define our interaction with advanced AI.